Hi, this is Chenxi Li, and today I'm going to introduce you my final project about for my Python course. Um, so first, I wanna give you my audience some overview and introduction about this project. So at the very beginning, I think I have to find a very interesting data set for my project. And luckily, uh, I find this specific data set that align with my goals and my interest. So this data set is about moral foundations and ready post data set. Specifically, what is moral foundations? Basically, sociologists categorized everything into um, several moral foundation domains. Everything, including speaking, sayings, emotions, everything. Um, so one very famous moral foundation theory is that um, there are five kind of moral standards: care, fairness, loyalty, authority, sanctity. But one thing is, all those moral foundations are very subjective. It will vary uh, uh, among people's opinions. So my research question has two parts. First, can large language model solve those moral foundation classification tasks? Second, how does it compare to the performance of traditional machine learning models? Okay, so let's go to my code parts, and um, you can also find the whole report in my repo. Okay, so first, as I said, we have my project contains two parts. One is baseline models, which is traditional machine learning models, and second is large language model experience. Okay, so first is baseline. First step is to load the data and import the libraries. Here we have model training libraries, metric libraries, and some graph and pandas libraries. Okay, let's see the dataset. The dataset contains text, the Reddit post, the subreddit, the post from, and the topic, and annotators and its annotation. There are two places need to be noted. First, each data point is annotated by multiple annotators, and so during the data process part, I have to unify the labels, unify the all the annotations annotated by different annotators into one label. Second, there are so many different kinds of moral foundation theories defined by different sociologists. In this project, I use the most famous one. There are five domains: care, fairness, loyalty, blah blah blah. But in this dataset, uh, the author of this dataset uses a moral foundation theory with seven domains. So another thing we need to do during the data process part is to convert seven domains into five domains. So this is the function for convert seven into five. Um, Basically converts purity into sanctity, combine equity and proportionality into fairness. Also, and the second challenge, there are multiple annotators for one specific data points. So we have to uh, group by all the different annotations together and unify the annotations, and so we can have one unified labels. The strategy I used here is, for example, there are three annotators, and uh, three of them gave three different answers, and so for this specific data point, it has three labels, three labels marked as one, and the other two marked as zero. And yeah, so we have a simple EDA step here, showing the distribution of the labels. Um, as we can see, care and fairness has much more data points. Then is the text length. I also examined the text length of different labels, and the graph shows that all those text has a very similar length, average length. And here's the result for baseline models. I choose two baseline models, random forest and logistic regression. Because we have five domains. Each domain is a binary classification problem. So we run uh, the training for five times. And here we can see the result. All of the result is between 0.5 to 0.6. It's slightly better than random guessing. So in this part, we can see that traditional machine learning model is actually not good at these kind of subjective um problem. And then I was wondering, okay, how can I optimize the performance of the uh, machine learning model without changing the model structure? As we all know, recently Transformer and other deep learning neural networks uh, outperform these kind of traditional machine learning models very much. But here we didn't think about it. Do we have other ways to improve the performance of these traditional machine learning models? Yes, we do. One way is to change the way we encoding the text. In the original baseline, we encode the text using TF-ID vector. This is very simple and standard used in natural language processing. Um, However, this dictionary based method is too limited. A new way is to use transformer model to do this job instead. Because this is better because the more complex the neural network structure can better capture the semantic meaning uh, he, hidden under the text. Um, and the transformer-based model can merge the semantic meaning into the um, vector representation of the text. But how do we do this? First, tokenizer. What is tokenizer? Basically, we separate the words into many parts, and in this way, we can tokenize a whole sentence into a tokenizer ID array. And with this array, we input the array into the neural networks, And with so many neural network layers, the array will be transformed into a mathematics matrix, which is called embedding. And this embedding contains so much rich semantic meanings about the text, which is better. Um, and with the embedding, we can see the optimized performance. And I draw the graph here. Uh, as we can see, actually surprising. Uh, After optimized, care and fairness and authority improves a lot, especially for care. This domain, the result is reached to 6.6, which is very high, but uh, oddly rainforest instead is lower. Uh, so this is all the result for baseline models. Next, I will quickly introduce the result for large language model result. Here, all the yeah, as I said, my goal is to become a AI engineer. So I learned large language model recently with many of my times. And one thing is API calling. So here, all these stuff is from OpenAI API using Doc. And using this function, we can deploy many different OpenAI and DeepSeek models and using them. Instead, Llama model is more complicated uh, because the time is limited. I won't introduce many more, but all these stuffs you can find from Hugging Face community. Uh, and yeah, pretty convenient. Uh, Then I will introduce two kinds of prompts I use. First, specifically, I specify the JSON format so I can catch the answer from the response more convenient. And I also have a much more complicated prompt, which contains the definition of the detailed definition of the domains. And I also have five shorts of in-context learning in exemplar in this prompt. Um, and we can see the output. Uh, Here, I did many experience. GB4, GB4 Mini, GB3.5 Turbo, DeepSeek, and Llama. Uh, so one thing is Llama, I spent many time on it. Why? Because it takes a very long time inference on such a huge data set. I use four GPUs, four A100 GPUs, and the inference time for the whole data set is about 20 hours. And the best performer is GPT-4o, uh, GPT-4o, and it is expected because GPT-4o is the largest model among all these models. Surprisingly, large language models are very good at doing these tasks. Uh, all of the results are outperformed the traditional machine learning models. And one interesting finding is the worst is DeepSeek. Why? I find that the DeepSeek has the worst instruction following ability. It cannot follow the guidance outputting the JSON format. So I cannot catch the correct answer from the response of DeepSeek models. And okay, I have 10 seconds left. So um, that's it. This is my project about using large language models and traditional machine learning models to do such subjective uh, tasks. And the result is Large models are very good at it. And I think this is a very promising direction and signal that we can use large language models to do more stuff. Thank you.